Boom. Oh, wait, where's my... Ah, yeah. Oh, boom. Okay. We've got problem number 1 for statics. Now, chapter 1 didn't have any homework. It was just learning, how to... I don't even know what it's called. Um, significant figures and conversions of units. Dimensional analysis. So here we actually finally get into what statics is, or at least the start of it. Okay, got your calculator? Because I didn't have mine. Okay, so we're starting out by giving P is equal to 75 newtons, and that Q is equal to 215 newtons. Now it says determine graphically the magnitude and direction of the resultant using the triangle rule. So we've got Q, which we can draw here, and then P coming off of that. And these are both from the vertical axis here. So P, we know this angle immediately, is 20 degrees, and this angle here is 35 degrees. We know that this is the vertical axis. This is 180. So this inner angle here, angle R is going to equal 180 minus 20 minus 35. And this also gives us the resultant vector. I can probably draw that better. Right here. This R is the resultant. This is the tip to tail method. All right. We go from the tail of this to the tip of this one, and that is the resultant vector of these two. Okay. With this, we get 180 minus 20 minus 35. That the inside angle here is 125 degrees. And that the resultant R, we can find this with the law of cosines. Law of cosines tells us that R is equal to the big square root of, this is going to be 75 plus 215, or 215, or 75 squared plus 215. Yeah, I think that's going to be it. And it's going to be minus 2 times 75 times 215 cosine of this angle that we just found here, little r, 125. So this means that r is going to be equal to, I'm going to actually plug this in now. I'm getting 265.23. And this would be newtons. And then we're asked to find the direction, the angle. So we know we can use the law of sines now, which says that what r is, so 265.23 over the sine of the little r that we found, 125, is going to be equal to the second force, which we have as 215. Or no, we have that second force here as 75. And that's going to be sine of, we can call this theta. Okay? So when you cross multiply this, we get that 75 sine of 125 is going to be equal to 265.23 sine theta. Now if we divide both of these by 265, we're getting that sine of theta is actually equal to 75 sine of 125 divided by 265.23. And then, of course, if we take the inverse sine of this, that means that we get theta alone. So theta is equal to, so I'll just do inverse sine of 75 sine 125 over 265.23. I mean, theta equals 13.39. But that's not the whole story. We've got this angle here, which should honestly be a little bit skewed this way. I think I drew it straight down, but it's not really straight down. In fact, it's going to be, if this was the axis here, it's going to be kind of like this. Right? And you're going to have Q here and this here. Right? So this is R. This is Q, and then this one's P. Right? It's going to look more like this. We know this angle here. That's going to be theta, and they want this. Let's see. Where do they want this from? This angle here. It's going to be probably from this axis here. So we're going to have this other angle right there. Now, what is this angle? It's going to be, see, this is going to be 90. We're looking for here. We're going to call it phi or something, right? So 90 subtract 35 gives us 55. So we add 55 to this. And we're getting 68.4 degrees. So this is our answer for the magnitude of the resultant, and this is the answer for its direction. And yeah, that is how you do that problem.